So thank you, Sridhar, for welcoming me to this wonderful webinar, and also to SIOS for inviting me to present EPB and its work here. I'd like to present to you a little bit of an overview and an introduction to the European Polar Board and how it works. So the EPB was formed in 1995 as a strategic advisory body to the European Science Foundation. It's been hosted by the NWO since January 2015, since it became its own legal entity. NWO have recently recommitted to hosting the Secretariat until December 2024, at least. Within the Netherlands, the EPB has been recognized as an organization of public benefit. So the European Arctic and Antarctic research community has long been a leader in cooperation across national and disciplinary boundaries. Throughout its 25-year history, the EPB has supported Europe's leadership on polar issues and has been working at the interface between research and policy across the widest variety of disciplines and issues. I invite you to join me in celebrating the EPB's 25th anniversary, which was initially intended to only continue in 2020, but because of the COVID crisis, we have decided to extend it into 2021 and have an extended 25th anniversary. We look forward to the next 25 years at the Conference of Science and Policy in the Polar Regions. So how does the EPB work? EPB's mission is to promote, coordinate, and advance European research in the high latitudes by providing a single collaborative platform for European polar researchers. We work with the EPB's work is aligned with its strategy, and you can access this on our website, and this really directs the core portion of our work. Organizations like the EPB are really effective due to the world-leading expertise that our members provide. All of these members, when collected, enable a strong, internationally authoritative voice to be heard on pressing polar-related issues. The EPB has recently welcomed its 28th member, and now we have members from across 20 countries around Europe. EPB members include a wide variety of organizations, including research institutes, logistics operators, funding agencies, scientific academies, and also government ministries from across Europe. Another strength of Europe is that we work in both the Arctic and Antarctic, making us one of the very few international organizations that have this unique bipolar vision. As you can see, we work with a wide range of partners, international European organizations, and also regional bodies that work in the polar regions. And SIOS is right at the center of things there, and we work quite closely with SIOS. One of our other strengths is that the EPB members have a very wide variety of infrastructure available as well. So EPB members own, operate, or manage over 60 polar research facilities that include stations, field camps, and many others. And there are ships that are specialized for operating in polar waters, and also specific aircraft that are dedicated to polar research. And like I said before, these are logistical capabilities in both the Arctic and Antarctic. The main idea is that EPB supports international cooperation in polar research. So how does it do that? EPB helps facilitate and encourage international cooperation activities, both between our members and also for our members. The EPB acts as a single contact point to multiple partners, that is our EPB members, and it streamlines collaborations within the international community. By coordinating internally and sharing knowledge and best practice, members are collectively able to reach out to international partners in a proactive manner with useful tools and initiatives that can promote and further develop international collaboration. The EPB's specific European focus also allows for addressing regionally specific issues for Europe. So how does the EPB work? The EPB works either with its action groups that are defined within our strategy, and also projects that are externally funded or are internal. So currently we have 5 action groups that are active, and these are specific defined activities that have a limited lifetime. I'll give you a few examples of these. The 3 main action groups that are currently active are the Action Group on Polar Infrastructure, the Action Group on International Cooperation, and the Action Group on Environmental Impacts of Polar Research and Logistics. You can find one of the biggest examples of what the Action Group on Infrastructure has produced is the European Polar Infrastructure Database, and this is available on our website. This is one of the things that we work very closely with SIOS on, and we are currently also working with the Southern Ocean Observing System to ensure that it is included within our database. Please look out for further updates on our website. The next example is our Action Group on Environmental Impacts of Polar Research and Logistics. And this group will take forward the recommendations to develop a set of best practice guidelines for the EPB members and also others to help minimize the environmental impact of their work in both the Arctic and Antarctic. We have various areas of focus, and you can have a look at this information on our website as well. So one of the expected outcomes is that we are going to produce a synthesis report on this, and this will be available for, we'll have summaries for various stakeholders, which will be publicly available. The third and final quick introduction is the Action Group on International Cooperation, and this leads EPB's activities in the area of international cooperation. They also identify practical opportunities for effective and mutually valuable international cooperation activities. These are just an example of some of the things that that have been carried out through this action group. So a quick look at the projects. One of our flagship projects is called Choice Epidemiology, and it's a wonderful collaboration between all of the different organizations on the slide. And it came about because, like I said, EPB acts as the central contact point for all its members, and we have an active memorandum of understanding with ESA. So this project seeks to inform space travel and the health of people doing space travel, but it also translates to the better health of employees that live in long-term isolation at different Antarctic stations. We are also quite heavily involved with EU PolarNet 2, which is recently started, and it's the world's largest consortium of expertise with 25 research partners. We are also working with MOSAiC, which is the Southern Ocean Carbon and Heat Impact on Climate. And you can find more information on MOSAic's website. We are also working with Interact quite strongly. And we are a cooperation partner with the EU Polar Cluster, which aims to bring together all of the different EU-funded polar research projects. Jointly, the EU Polar Cluster are aiming to provide policy-relevant information and support the EU in implementing its integrated policy for the polar regions. This was an example of an activity which was carried out through the EU Polar Cluster that partnered with ESA's Polar Cluster as well. Some of the quick communication activities that the EPB does, so you can keep informed of what we're doing and any upcoming activities. We have YouTube channels which has a wide variety of different webinars, information webinars, and also EPB member webinars. We are quite active on both Twitter and Facebook, and you can also subscribe to a mailing list on our website. And I promise we don't spam you. We only give 1 or at the most 2 emails per month. So you know that if emails are coming from us, then they're fairly important. So this is our YouTube channel. We also had, and these are a couple of examples of our communication activities. We had a knowledge sharing meeting between EPB members affected due to COVID crisis, and we've also coordinated a meeting for the same knowledge sharing aspect within the EU Polar Cluster and its projects. We are also working with the organizing committee of the ASM3, and the next webinar is coming shortly. So I would suggest that you can go to the website and register for the upcoming webinar, please. All of these webinars that have been held are recorded and are available on the EPB YouTube. Another upcoming activity is a special session at ASSW on the 23rd of March between 3 o'clock and 6:30 GMT or UTC. And this is an activity upcoming in the summer of 2021, and we will be hosting a meeting on the UN Decade of Ocean Sciences, particularly for the Southern Ocean regional perspectives. This will be held with the Polar Data Forum. Again, please subscribe to our mailing list and we will ensure that you have the latest information. Thank you very much. And I hand over back to SIOS.
So today's talk, I thought I'd tell you a little bit about the work I'm doing in the Climate Office. Oh, sorry, my camera's gone off. Can you still hear me? I might leave the camera off just because my internet isn't great. Is that all right? Yeah. Okay. So yeah, my talk is all about the work we're doing in the Climate Office. In particular, I'm going to give you a few examples from the High Arctic as well. But first, let me tell you about the Climate Office. So the Climate Office runs this program called the Climate Change Initiative Program. And the main objective of this program is to help characterize the Earth's climate and its change by creating long, consistent, error-characterized climate data records using the entire satellite archive. So just to give you the definition of a climate data record, it's a time series of measurements of certain variables that are crucial to characterizing our planet's climate. So it needs to be of sufficient length, consistency, and continuity so that we can determine climate variability and change. And of course, climate data records can be created by merging data from surface, atmosphere, and space-based systems. So it's not just satellite data. And the whole concept of the Climate Change Initiative Program goes back to 2007, after the COP13 and the climate conference in Bali, when it became apparent that the space agencies were way behind the curve in supporting the climate science community from satellite observations. So what was needed were these long-term multi-mission consistent unbiased error-characterized data sets of essential climate variables that had already been identified by the Global Climate Observing System back in the 1990s. So the European Space Agency then set an activity in motion that would change the way we dealt with thematic data products and help us arrive at these climate data records. And that's the CCI program. And it's the agency's contribution to strengthening the systematic observations of our climate system as laid out by the UNFCCC and more recently reiterated in the Paris Agreement. So the CCI program is a rather large endeavor that covers global scale data sets. But as this is all about Svalbard, I thought I'd sort of focus a little bit on the High Arctic and give you a flavor of the science we've been doing in the High Arctic. So of course, you all know about retreating sea ice extent, and in Europe we have the EUMETSAT OCSAF Sea Ice Climate Data Record, Sea Ice Extent Climate Data Record, which is developed from passive microwave sensors. And the CCI program actually contributes to some of the research and development activities for this particular product. You all know this is actually just the graph that you all know of the seasonal cycle of sea ice, but of course it's the downward trend that's important. But it's not just extent that we have to look at, we also need to look at sea ice thickness, because sea ice, of course, has volume. So this is where we use the satellite radar altimetry record, which dates back to the 1990s, first with the European Space Agency's ERS 1 and 2, then ENVISAT, and following those satellites, we now have CryoSat-2, which is ESA Earth Explorer. And it is the CCI's job to merge these satellite data streams to create an unbiased climate data record. So that's basically bottom line of CCI. Here's an example of a consecutive sea ice thickness record for CryoSat-2 and ENVISAT. So this was developed in the last phase of a CCI. As you can see, the retrieval in the Northern Hemisphere is limited to the winter months between October and April only. And by comparing the sea ice thickness maps, you will also note that CryoSat-2 gives us improved coverage with a much smaller pole hole reaching latitudes of 88 degrees north. And of course, CryoSat-2 is, advanced radar altimeter. So we can also see how technological advances have improved the spatial resolution of the data. And we're currently developing the algorithm that will let us extend the climate data record backwards in time to the ERS period, but that comes with its own specific challenges. It's basically the CCI's job to figure out how you can merge these data and make sure that you are not introducing any biases, so that you actually do have a consistent climate data record. I thought I'd put this in, and you'll hear about MOSAiC later, but of course the agency, so this is actually not work that is done in the Climate Office, but some of our scientists have been funded through other budget lines in ESA to do some experiments on the MOSAiC expedition, which were in particular related to snow on sea ice, and they put up this nice, they contributed to putting up this nice experimental seaflow. Now let's look at Svalbard, because another of my teams, the CCI Glacier project team, they actually do a lot of work on monitoring glaciers in Svalbard, because as I'm sure you're all aware, these glaciers are behaving very interestingly. So, but let me first tell you all about the variables we can monitor from space and the different sensors we use to do this. So let me introduce you to modern day workhorses for glacier monitoring, Copernicus, Sentinel-1 and Sentinel-2. These are both two satellite constellations, and they both carry dedicated instruments. So Sentinel-1's payload is a synthetic aperture radar, and Sentinel-2 carries a multispectral instrument. And the CCI Glacier team uses these sensors to develop algorithms to monitor glacier extent, glacier velocity, and they also look into glacier elevation changes. And they can do the glacier elevation changes. They can do this with the aid of altimeters such as CryoSat, but also existing digital elevation models. Okay, but let's focus on ice velocities from Copernicus Sentinel-1. And as a reminder, Sentinel-1, of course, is a synthetic aperture radar, so it can also work during the polar night, so it's throughout the entire year. Okay, here's an example from Svalbard. This is Strongbrain. My team who's been working on this in particular would like to mention Frank Paul at the University of Zurich, who is the project lead for CCI Glaciers. But of course, also in Oslo, we have Andreas Kerb, who's working on this. So you can probably see in this Copernicus 2 image that the Strongbrain Glacier is crevassed right to the top because, of course, it is currently in full surge mode. So you know, glacier surging is a type of instability where the glacier starts to accelerate steadily over several years and then suddenly bursts into very rapid acceleration. And then finally, the glacier then gradually ends this fast flow phase. Now, of course, the underlying processes are still very much an open research field. And it is established that glacier surging is not climate driven, but we still need to keep an eye on how the rapidly changing Arctic is affecting glacier dynamics in general. So this is why we're interested in this, and because one thing is for certain, we're seeing a lot of glacier instabilities, which may be dominating the calving flux from the Arctic ice caps and glaciers. Yeah, and here I have an animation, and you see a time series of Sentinel-1 data of Strongbrain, which is used to track how the flow velocity is evolving over time. So the amazing thing is that now we have the Copernicus satellite system in place. We have increased satellite coverage that allows us to retrieve ice velocities over short periods and enables us to look at fast-flowing glaciers, even surge-type glaciers, such as the many that exist in Svalbard. Yeah, and my team have done this for several glaciers across the globe, and many in the high Arctic. And here you can see Canadian North, Novaya Zemlya, Franz Josef Land, but also, of course, Svalbard on the bottom left, and of course, of particular interest is the Ostfjorda ice cap, which I'm sure you're all aware of, has got a lot of surge activity happening. And this is also illustrated in the time series here of ice velocities. So it's really amazing how we can now use the wealth of Sentinel data to examine the evolution of surge type glaciers from space. That's really a revolution, really. And finally, I think I've gone over time. I'm going to bring it back to CCI program in general, because I would like to stress once more the importance of the long-term record. And I know long-term observations are important to SIOS as well. So in terms of Earth observation, the EU's Copernicus program is doing a really great job for systematic observations. But for climate, we need more. For climate, we need to also dig into the satellite archives and use the old data to create these consistent climate data records. Because only with reliable observations can we improve our understanding of our planet, and satellite technology is really here to support that. And I'm going to stop there. Thank you very much.
Thank you. As you said, I'm an associate professor in sedimentary geology. It means I'm a sedimentologist, and I work with the physical processes on the Earth's surface, and somewhat more ground-based than Anna-Marie, who went before me, but I also need remote sensing data, so that's how it fits in here. But I'm most of my time working on actually ground truthing some of these data. So that's, and I want to do two things today, and thank you for inviting me. But when I received the invite for this International Women's Day special webinar, where you only invited women, given that you hadn't invited me before and there were very few women in your previous webinars, I was a bit hesitant, as I told Inga Jennings, who contacted me, whether to say yes or not. I decided to say yes in the end, but I would not let it go totally without comment why we're doing this exactly today and why you're asking women to present exactly today. So I'm going to come back to the science, but first I'm going to show this slide, which is part of the reason of my reasoning for accepting the talk. I've worked on Svalbard coastal change for the past 12 years. And these are some of the people I've been working with, and some of them are women and some of them are men. And there have been lots of people involved in this work, both colleagues and students. And I think on this day of the year, there are often these pictures of women in the field floating around as a celebration of kind of to show that we made it in science. And in many ways we did, but I also want to talk a little bit about what's at the end of this webinar today, which will end in this panel discussion. And all these excellent students, female students and colleagues that I'm going in the field with and we're doing this work with, they and I are also in this unfortunate position that we are sometimes only invited to speak one day of the year, or struggling a bit more to get through to the attention than some of our male colleagues. And I've just listed some of the things where there is research documenting that there is implicit bias against women, but also against other minorities. And that's, for example, in job recommendations, job applications, and teaching evaluations, even when other qualifications are equal. And also in speaker invitations for conferences, and whether people get oral or poster presentations or funding obtained. And in addition to that, there is often a cultural climate at work where women experience microaggressions, have less role models, and are less likely to receive mentorship and sponsorship. So I think it's worth thinking about that. All the females who are presenting here today and all our female students who we are bringing forward, and also other minorities, are actually fighting against this while still producing excellent results. And that's worth keeping in mind when looking at the actual results. And what makes a difference is representation. See someone like you doing the kind of work you want to do, role models, learning and talking about gender disparity and implicit bias, and mentorship and sponsorship. And that's why I decided I wanted to give this talk, because I want to show other younger women, all my colleagues, that what we do, engage with the community, be part of the solution, improve collaboration, and also provide opportunities. And that is one of the things we can do that are listed in this little figure here on the side, that we actually provide opportunities to people, invite them to give talks. And that means you should not say no when you're actually invited to have a word. So I want to go back to the scientific content. And what I'm working on is coastal change in a large part of Svalbard by now. And as you are probably aware, there is rapid coastal change going on in the Arctic. It's not as dramatic in Svalbard as in some other places, because the land is still rising after the glaciation. So there is some buffer, but there is still permafrost thawing, and there is also a rising sea level, and there is more open water and less fjord ice than we used to have. And it has implications for infrastructure, for example, as you see in some of these newspaper clips, cultural heritage preservation, and also for increased sediment transport to the fjords, which has implications for the fjord ecology and the light climate in the fjord waters. It also has implications for wetlands, the configuration and placement of wetlands and size that is changing, which may matter for terrestrial, for example, bird life. So this is a very interesting topic, but when I first started working on it, I found out that very, very little work was done. Actually, so little that the coastal maps are often a kind of classical topographical map like Topo Svalbard. It's very inconsistent in the shallow marine area. There is bathymetry data in the deeper part of the fjords, but it's very poor when you come close to the coast. And often these data are also old. So the very rapid changes where the coastline can move, either erode or prograde tens of meters in a few years, is not covered in traditional topographical maps. So what we're doing is that we are relying heavily on remote sensing. So we need aerial photos to actually reproduce the coastline. And then what we also need is an understanding on what is actually going on onshore, be able to predict what might happen in the future. So we need to understand the processes working on the shoreline today and in the past in order to be able to say something about which areas might be vulnerable for future change, which ones are likely to be exposed to erosion, which fjords or bays are likely to fill up with sediment, for example. So with colleagues from the Norwegian Geological Survey, we have had an ongoing project where we have mapped the entire coastline of Isfjorden for the first time ever, and produced by now a number of public maps for selected sites in the quality that you see here on the side from the Dynacoast data. When I started doing this work about 10 years ago, there were a few localized coastal studies. There might be a few studies that I have missed here that I'm not aware of, but the characteristic was that it was small groups, primarily Polish scientists and my own collaboration group who started working in Baganservågen, marked in the middle, and a small group, another small group from UNIS also who worked in the Fredheim area. So there were a little bit of activity here and there, working on small sites, understanding that local part of the coast, but no coordinated effort. Status now is that we have worked in all these areas marked by red, not only me, also the Polish groups who worked here in the past and other people from UNIS who worked in the past. Work with French colleagues in Kongsfjorden and with French colleagues on part of Isfjorden area, and with various Norwegian institutions, German, Korean, British, many different nationalities have been involved in this. And we have by now covered many individual sites, but also some larger areas, as I mentioned, Isfjorden. There are also now maps of Baganservågen, and there is more extensive work done in Dixenfjorden. And this is the kind of way we've been working with the mapping. So we have little pieces around the coast. This is the inner part of Isfjorden. And we've been working for each of these little squares that you can see with the lines. There is a detailed map. We can of course not print this entire map, so it exists now as a large digital data set that is temporarily stored with us because there is no good data storage source for these kinds of data for Svalbard. And this is what it looks like in detail. They even mapped in more detail than this, but this is what they actually look like and the type of map material we are able to produce. This provides a baseline for future coastal change. In addition, we have some localities where we worked in more detail, for example in Dixenfjorden, where we're looking in more detail at how the coast actually behaves and also dating the change and looking at migration of the delta front. And a similar example from Svea and Baganservågen, where we have followed the coastal system also by now over about 10 years. So my last slide, the ambitions for this coastal effort is to expand this morphological baseline mapping, because if we don't have a baseline, we can't say anything about what's happening in the future. And build on this website that we have developed to provide an open access site for coastal change data to increase collaboration. And I have a new project. We have done very little because we were delayed by the pandemic, but the Moving Coast project that started in 2019, we just had 6 months, then we were more or less shut down by COVID, but where we were using Sentinel satellite data to measure coastal change remotely. So that's the kind of future ambition, and that's where also the link to remote sensing at SIOS comes in. And through these tools, improve interdisciplinary collaboration through onshore, offshore linked projects.
So I'll sit up here.
So
Hi,
can you
everyone.
hear the...
Happy International Women's Day, and I just want to give a big thanks out to the SIOS crew for inviting me to give a talk today. I am now back in the United States after spending a number of years in wonderful Arctic Tromsø, and of course in the UK for a few years. I'm working now as an independent consultant and have been lucky enough to be involved in both the Arctic Science Ministerial 2 and 3. So when I was asked to give a talk today, I started digging into the information from the 3rd Science Ministerial, and there was a lot of interesting things about how important Svalbard is for international Arctic science collaborations. So I thought I would just share with you a little bit of our findings from that today. So the third Arctic Science Ministerial is hosted by Iceland and Japan and will take place in Tokyo in May. It was originally scheduled for November, but because of COVID, it's now, that was postponed and is now going to be held in May. It is the third in a series. The first was held in 2016, hosted by the United States. And then in 2018, it was co-hosted by Germany, Finland, and the EU. And the point of this meeting is to bring together the ministers of science that have a stake in Arctic research to try and help align priorities and find ways to work together to better increase the amount and the quality of international science that's going on in the Arctic. So who are the participants of the Arctic Science Ministerials? For the third one, we have 29 different countries or governments, as well as 6 Arctic Indigenous representative organizations and 16 international organizations with an interest in either Arctic science or education or both. So the big group of folks coming together to talk about Arctic research. We have a wonderful science advisory board that's helping to put together and synthesize all the science going on. It's made up of representatives from Iceland and Japan, the host countries, as well as representatives from the Arctic Observing Summit, APEX, IASA, as well as an Indigenous knowledge holder, as well as a representative from Indigenous Science, SAON, and the University of the Arctic. I am serving as an ex officio on this committee and helping to synthesize what they find is important. So just what kind of information are we talking about here? We've asked all of the countries and organizations that are participating to submit Arctic research overviews. So what's going on in their country or organization dealing with Arctic research? How is it funded? What are their priorities? What types of facilities do they have that are involved in Arctic research, be it ships or satellites or research stations? We asked them for updates from projects that were submitted to the second Arctic Science Ministerial, as well as if there are any new projects going on that will help with the goals and themes of the third Arctic Science Ministerial. And new to this one, we also gave countries and organizations a survey asking questions on international collaboration and cooperation. This was crucial in helping to identify opportunities that countries offer for bringing in international scientists, as well as areas where they felt more international collaboration was needed. We also asked for feedback from the science community directly through several online feedback forums, as well as a research community workshop, which was hosted by IASC, IASA, and APEX last summer, the ISAR conference, as well as the Arctic Observing Summit. So just as a disclaimer, the information that I'm presenting today is on projects that were submitted by countries or by countries. They were asked specifically to submit ones that they felt were important as far as either helping to facilitate more international collaboration or international projects that they already have going on. However, countries chose to pick those projects is up to the individual country. So here we're just synthesizing the information that was presented. This will help to form the joint statement for the Arctic Science Ministerial, as well as the science summary report and a number of web resources that will be available to the community afterwards, including a comprehensive list of the opportunities and fellowships and things available for scientists to move or to study in different countries or to do research exchanges. And all of this information will be put together as a layer on the Japanese Arctic Data Service. So you will be able to find all of this soon, hopefully. So the themes for this third Arctic Science Ministerial are observe, understand, respond, and strengthen. And this is moving on a continuum or iterative step. So first you look at things and then you try to understand them better, figure out how to respond to those changes, and then strengthen the community as well as the resources that are available to help in those responses. So that's the theme of this Arctic Science Ministerial. So getting to the projects themselves, there were 426 projects submitted, 174 updates from the past ministerials and 252 new ones. So that shows that there's a growing increase in the Arctic Science Ministerial process. So the word cloud on the left is keywords from all the projects. And you see some major Arctic research themes that are coming out: monitoring, observation, sea ice, cryosphere, modeling, ecosystems, and ecology. On the right, you will see the number of countries that were listed as collaborators in the different projects, and shows you get a pretty good representation here of the countries that are involved in Arctic research, and the breadth or the amount of research going on in those countries. So why did I decide to talk about this on a webinar for Svalbard? Because when I put together information on where all of the science was going on, Svalbard popped out as one of the major hotspots for where international Arctic research is occurring. And so that's what the word cloud on the left represents. So out of the 426 projects that were submitted by countries, 110 involved Svalbard in some way or another. So that's 26%. That's a quarter of all Arctic research submitted to the ASM3 process involves Svalbard. So a key area of international research. So most of the projects that listed Svalbard also listed other parts of the Arctic as places where their project involved research. So this shows that Svalbard is a very important component to research that's going on all over the Arctic. Often it was a site or a launching off point for other remote sites. So it's an important part of larger international Arctic, particularly observing efforts. Only 19 projects that were submitted involved Svalbard only. So who's doing research on Svalbard? The word cloud on the left represents the number of projects that countries submitted involving Svalbard. So naturally, you would assume Russia and Norway with their bases and stations in Svalbard had a large percentage of their projects submitted that deal with Svalbard, as well as Italy and Czech Republic. A great percentage of what they're doing involves Svalbard. So then when you take a look at all the countries that are involved in those projects that are submitted, so what's the breadth of collaboration of countries working on Svalbard? All 29 countries that are participating in the ASM3 had some involvement in research projects going on in Svalbard. So that shows that all countries doing research in the Arctic have an interest in Svalbard and how important it is to helping us understand what's going on in the Arctic. Looking at it from another perspective, some countries have all or most of their research happening on Svalbard, showing that it's an important area in facilitating Arctic research collaboration. So for example, Thailand, 100% of the research that they're doing in the Arctic involves Svalbard. India and the Czech Republic also find or show that Svalbard is a very important place. So over 7 countries with the projects that they submitted dealt with 50% of their research dealt with Svalbard. 63% of the countries, so 12 out of the 19, were non-Arctic countries. So again, showing that Svalbard is a very important place for facilitating Arctic research. So what are the research topics that are happening in Svalbard? Here you have a word cloud on the left of all the projects that are happening in the Arctic, their research that was submitted and their keywords. And on the right are the ones that involve Svalbard. And you see the same important words or themes of research popping up: monitoring, observation, cryosphere, climate, ecosystems. So showing that the breadth of research that's happening with Svalbard is representative of the Arctic research that's going on as a whole. Other interesting things about the work going on in Svalbard, most of the work is involving natural sciences, so biology as well as physical sciences, very little social science or arts and humanities, and not very many dealing with indigenous knowledge. The projects only dealing with Svalbard, 95%, so almost all are natural science focused. The amount of outreach on Svalbard only projects is relatively low compared to projects that involve other areas. And the education and capacity building of all Arctic research still has a ways to go, with only 5% of all the projects reporting education and capacity building as a theme for their projects. So just some things to pull out. Again, most of the research happening on Svalbard is natural sciences, which I think we all understand and know. So the questions then arise is there a need for more social science research on Svalbard? Is there a need for community-driven research? There are towns and research facilities. Are there studies that can be done to help the folks in Longyearbyen, for example? And does that need to be done on an international level? Some interesting questions that can come out of this information. So this is just a brief overview of what's happening on Svalbard. You can learn more about what is going on internationally. If you haven't already, we're our wonderful partners at the European Polar Board, Renuka and Joseph and the guys are helping to put together a webinar series for the Arctic Science Ministerial. We're having our third one coming up here in March. Check out the website for recordings of past webinars, as well as the future information. And yeah, we'll be sharing a lot more of what we found over the coming months. So just a shameless plug, another side project that I'm working on with a friend of mine that I met on Students on Ice. If you don't know that organization, it's a great opportunity to get young people involved in appreciating the Arctic. We have started a fun little company called Beaker Babes. And we're right now putting together some jewelry and wine charms and things with a science theme to try and show the fun side of science for a change. We also have a number of polar things, of course. So if you're looking for some polar bear earrings or a penguin keychain, we have it for you. So check out beakerbabes.com. In the coming months, we'll also be putting on a number of other fun activities or fun projects for you or fun products for you, including my favorite Seize the Data data notebook. So stay tuned and check us out if you're interested. So again, just thank you very much to the SIOS group for inviting me to give this talk. I hope it was interesting and that you learned a little bit more about the Arctic Science Ministerial, and hopefully we will have a lot more to share with you in the coming months. So thank you again.
Okay, yeah, so I was asked to tell a little bit about the logistics challenges during MOSAiC. Maybe just briefly for those who don't know what MOSAiC was. So MOSAiC stands for a multidisciplinary drifting observatory for the study of Arctic climate. And it was, well, maybe the biggest Arctic expedition up to this date, and happened from September 2019 to October last year. So the idea was to do a bit what Fridtjof Nansen did a couple of 100 years earlier, basically freeze a ship into the ice and follow the ice drift. And during that time, measure everything that's going on. And especially, I mean, there's been several drift stations and drift expeditions and Arctic expeditions, but especially throughout the polar night, and especially over this whole time frame of a year, there's just not enough data, or not that much data. And yeah, so that was what was planned, putting Polarstern, that's the German icebreaker, into the central Arctic, setting up a network of camps on the ice and distributed stations a bit around Polarstern, drift for about a year and do all sorts of measurements. There was visits planned by other icebreakers, and there was also outreach other operations planned by aircraft, helicopters, and also lots of satellite data taken at the same time. So of course the challenges that we met, the Arctic for sure, in general brings challenges. So it's the isolation. We were in the very central Arctic, up to 1,500 kilometers from the next settlement. It was very cold. I think the coldest temperature that was measured was -42 degrees. For several months, it was polar night and dark, and that brings challenges by itself. It's extreme weather conditions. Everybody living and having been up in the Arctic knows that. There was a lot of storms. There was fog in summer. And of course, the sea ice itself brings challenges by itself. It's moving, there's breakups, there's leads, cracks, and then afterwards also ridges that have effects on instruments and setup of installations. And polar bears. We had visits of about 60 polar bears throughout the year. And then another challenge for this expedition in particular was definitely the scale of operations. So it was the central observatory, ship-based, and also on the sea ice. Then there was a distributed network with stations all around that had to be set up as well. And also some of them had to be visited throughout the year. And that went up to 50 kilometers away from the ship. And then there was the Arctic-wide linkages, of course, collaboration with the aircrafts and satellites and lots of other Arctic buoys that were already in place. But all of that, of course, had to be coordinated. And yeah, so the operation of the expedition was planned through the course of a year. So in total, we were out for 389 days. There were more than 80 institutes from 20 nations involved, 337 scientists and experts, and 105 crew members were in the field in total, and several hundreds more were involved on land. On board, there was always 5 scientific teams. They were studying the sea ice, the atmosphere, the ecosystem, the oceanography, and also the biogeochemistry, and those all had to collaborate. And there was numerous projects involved that all had to work together partially, or had to see how they can come up with how can they sustain their projects throughout that year. All these teams have got support by 5 support teams. That was the logistics team, but there was a data team, there was a helicopter team, there was a weather service, and a media team as well. There was up to 70 metric tons of equipment and a lot of monitoring stations on the ice. So the length of the operation was a challenge by itself as well. Of course, there's very different conditions throughout the year. So we had to think about the equipment we need, what is suitable for both minus 40 degrees, but also when it potentially leads to thinner ice and wet conditions. How do we have to put up our safety concept? How can we train the participants and inform them and make sure that all these people from all over the world, from different institutes with different backgrounds, I mean, I would say most of them had a lot of experience and many were really, really good and well trained. But then there was others for whom it was the first expedition ever. So to put all of them on the same page and make sure they were safe, that was a big challenge in the beginning. And of course, a lot of infrastructure on board and on the ice. Meaning, yeah, who gets to get which space? How can we set that up? And what interferes potentially with what? So there's a lot of coordination needed for all that. And then maintaining the camp, of course. My job particularly was also a lot of the general logistics infrastructure, and that, of course, again changes throughout the year. The conditions in October when we set it up, the ice was only about 30 centimeters thick where the old melt ponds were. It was much thicker where there was old ice and ridges. But then, of course, it got a lot thicker. We had a lot of breakups. In summer, again, we came to this thin ice and very wet conditions. So that changes things, and different to maintain things at minus 40. Good example is these power hubs, for example. They were, of course, made to sustain temperatures at minus 30 and below. So they need to be isolated and all of that. But then again, in summer when it was very wet and we had to move things around rather quickly, they were absolutely not suitable. So we had to adapt throughout. So yeah, up to 70 metric tons of equipment. Always the question of limited storage space on board and also on the camp versus redundancy and safety, because we were so far out and well, there is no shop. I think that's the case for most expeditions. And same, how to organize things on board to have accessibility throughout the expedition. You cannot just put your container and store it until it's full, then put it on the ice and unload it completely. Literally everything needed to be stored so that we could reach everything, and the ship also couldn't be used, that it could be unloaded completely and then loaded again. There was instruments installed all over, and also the teams. There was a lot of knowledge transfer needed from each team to the next, because most people were exchanged. So to keep the others, make stable that they could find everything and use everything, and that people afterwards would know what had been going on. That was quite a challenge as well. And of course, the general broader logistics that were needed for this operation was we needed an emergency network for medevac operations, given that we were for a long time of the expeditions out of reach for the medevacs from Svalbard or Greenland or Norway. So we had some fuel depots in Russia and some plans that we could use with Russian helicopters or planes. And there were 6 other vessels involved in the resupply and support, which led, of course, also to cargo operations on the ice, which was each time a challenge and each time differently done. And each time we had several plans and had to see how conditions would allow us to approach the ships together and then in the end do it. And the runway preparation, that was a huge theme. One of the exchanges was planned to be done by aircrafts. That was in spring when, well, the ice was supposed to be very thick and also hard for ships to come up. So the runway had to be made to then do the exchange from Svalbard via Antonov aircrafts. To build this runway, of course, especially for a length that was needed for aircrafts this size, that needed a lot of special equipment and a lot of preparation. Yeah. In the end, Corona was definitely one of the biggest challenges of this expedition, as it happened pretty much in the middle of it. From March onwards, there was international travel restrictions that literally changed the rules of the game that we'd all been playing. The aircraft campaign with the aircraft Polar 5 and 6 that was supposed to start from Longyearbyen had to be cancelled. Also, we couldn't simply fly people in and out to Longyearbyen anymore. The icebreakers that were supposed to do the exchanges afterwards were no longer accessible. So the exchange in general was not possible anymore as it was. And also just to find ships that were willing and able to do that sort of exchange, plus also to make it possible for us to do an exchange in a safe way that makes absolutely sure that we do not bring this virus into the Central Arctic without any quick access to any hospitals or medical centers. That was, yeah, a challenge itself. I mean, we're a bit more used to it now. In March last year, this was all very new to a lot of people, I think. So we had to nice quarantine hotels and testing capacities and a concept to really make sure that this goes along safely. And in the end, the exchange was done. The first exchange then was done about a month and a half later in Isfjorden with the German research vessels Merian and Sonne, and then another exchange was done in the Arctic and further in the ice again with the Russian vessel Tryashnikov. Yeah, I think I was maybe much quicker, but maybe that's okay. That's it.